I'm Amit Yadav, and today I'll be presenting my research on comparative analysis of page replacement algorithms, evaluating the efficiency, implementation, and real world applications. So, this presentation examines how different page replacement strategies impact system performance, comparing traditional algorithms with the newer approaches, including hybrid and machine learning based techniques. And as an introduction, let's start by understanding the fundamental problem. The virtual memory is a critical component of the modern operating system that allows us to run more programs that can physically fit in RAM. It creates an illusion of a larger memory by using a two-level hierarchy, the fast main memory and slower secondary storages. When a program requests a page not currently in a main memory, a page fault occurs. So the operating system must fetch this page from disk, a process that's significantly slower than accessing the RAM. And as a background, the page replacement algorithms have one primary goal: to minimize the page faults by evicting the pages least likely to be needed soon. The concept dates back to the pioneering research in 1960s and 70s, where computer scientists sought to understand program behavior and develop optimal algorithm. So as shown in the diagram on the right, when a page fault occurs, the systems must identify a victim page to swap out, change its status to invalid in the page table, and bring the request page from disk. In this presentation, we'll analyze three classical algorithms: first in, first out, least optimal used algorithm, and theoretical optimal algorithm. And we'll also see some of the new algorithms, as I showed some of the basic, not basic, machine learning algorithms and some hybrid algorithms which is proposed. So that is the new part in this research that I have covered. So let's start with FIFO, the simplest page replacement algorithm. First in, first out. The implementation is straightforward, requires only a FIFO queue that stacks pages by arrival time, making it very slow overhead. However, FIFO has a significant limitation. It does not consider how frequently a page is accessed. A heavily used page stays in memory for the same duration as a rarely used one. And apart from that, FIFO also suffers with Belady's anomaly, and counterintuitive situation where increased memory size can sometimes increase the false rate rather than decrease it. And in the least memory used, LRU implementation requires tracking the last access time of page, typically using linked lists or timestamps. This approach generally performs better than FIFO and often approaches the performance of the theoretical optimal algorithm. So, however, LRU has its own limitations. The overhead of maintaining usage history can be significant. It can also exhibit a plateau behavior with certain applications, where increasing memory does not reduce faults until the entire working set fits. And this is the optimal algorithm that has been proposed with the principle of replacing the page that will not be used for the longest period of time in the longest period in the future. And the mechanism is like, look ahead in the memory references string to find the page whose next reference is furthest in the future. And as an limitation, we have impractical to implement in a real world because it requires a future knowledge of memory access. And as a computing evolved, researchers recognize that traditional algorithms struggle with diverse and evolving memory access patterns. These led to more sophisticated approaches. One is SEQ, which detects the long sequence of the page faults to contiguous addresses. And for this sequences, it applies more recently used, that is MRU replacement, defaulting to LRU otherwise. Simulations show different significant performances, which is included in the research paper as well. Yeah, and the hybrid algorithms combine strength of different strategies. For instance, like hybrid page replacement algorithm integrates concepts from FIFO, LRU, and optimal with a frequency counter. It prioritizes the replacement based in future prediction frequency and the past prediction, using FIFO initially, then switching to a more sophisticated approaches. And in here, uh, this slide shows a real experimental comparison between algorithms. The top figure displays the optimal algorithm with 11 page faults of a 3-frame memory system. And the bar chart in the bottom provides a comprehensive comparison of a page faults counter across all four major algorithm times as expected. FIFO shows the highest number of faults at 15, followed with LRU with 14, optimal with 11, and the hybrid approach demonstrated the best real world performance with only 10 faults, 10 page faults. So these results confirm that the well-designed hybrid approaches can sometimes outperform even the theoretical benchmark in specific scenarios. And if we see the learning-based page replacement, this is more of the machine learning type of page replacement algorithm. So taking algorithm evolution a step further, researchers have began applying machine learning techniques to page replacement decision. This approach aimed to learn memory application memory access patterns over time and dynamically select the most appropriate policy. So as and when the AI and machine learning is evolving, I think this is one of the most interesting part that I have referred while referring different research paper. And many implementation use reinforcement learning where the algorithms learn through the rewards and penalties based on the eviction outcomes. The goal is to minimize the regrettable decisions, likely evicting the page that will be needed again soon. And two notable examples are LPR, learning based page replacement, which learns from the eviction history using both LRU and MRU as candidates, and ML clocks, which integrates neural networks to create an intelligent eviction policy that consider out, media attributes, storage media attributes. The key advantage of these approaches in this ability to adapt changing workloads without requiring. And this is the performance analysis. Extensive studies comparing the algorithms reveals in several key insights where we see HPRA shows promising results by reducing page faults rates. However, it's important to note that performance heavily depends on application characteristics like memory capacity and medium speed. Newer algorithms like MGLRU can exhibit high variation in runtime and page fall rates. Cross identical execution or different configuration, possibly due to this scanning overhead or inconsistent scanning behavior. And in this, we'll see the in practice operating system rarely implement the theoretical algorithms directly. The optimal algorithms isn't feasible for online implementation, and even perfect LRU has a prohibitively high overhead. The modern operating system generally uses approximation clock algorithms, and the common LRU approximation uses in the circular lists. Linux traditionally uses a form of clock LRU approximation but recently adopted to the multi generational LRU, that is MGLRU, which replaces simple active inactive lists with multiple generation lists. And in the in this slide, like to conclude, overall the significant performance gap between memory and disk makes efficient virtual memory management crucial for overall system performances. While the optimal memory algorithms represents the theoretical bests, its practicality, necessity, practical alternatives, advances, and learning-based algorithms shows a promising in adopting in diverse workloads patterns, but introduce a new consideration around overhead and configuration dependency. And as a future work should focus on developing most robust algorithms, improving the tracking efficiency, exploring and interactions between page replacement and other memory management techniques. and investigating energy efficient consideration. The field continues to evolve with ongoing research towards algorithms that can better adapt to increasing complex and diverse computing workloads. And that's it. Thank you for your attention. I'm happy to answer any questions about the research presentation in case if it is needed.